introduce you to the key component of X-ray machines and how they work together to create a radiograph like this or like this. Okay, so first, this is the X-ray tube, which is the heart of X-ray machines and it's also the source of X-ray. So how does that happen?
The X-ray tube can be classified as internal and external. The internal parts include cathode, the filament that causes thermionic emission, anode, a flat disc that made of tungsten that draws the electrons across the tube, and the inside of the tube is vacuum so that the X-rays are produced isotropically. While the external part includes tube support, protective housing, glass or metal envelope. X-rays are produced in an X-ray tube when high-speed electrons collide with a metal target. So first, the filament in the cathode is heated, releasing electrons through thermionic emission. A high voltage accelerates these electrons to the anode, where they strike a tungsten target. This interaction produces X-rays in two ways. First, Bremsstrahlung, and second, characteristic radiation. Bremsstrahlung is where electrons are slowed down near the tungsten nuclei, and characteristic radiation is when electrons knock out initial tungsten electrons. The resulting X-rays are directed through a window, filtered and shaped into a beam for imaging.
So the next component is the generator. Here in our hospital, we are using high tension generator. The function of the generator is to supply the current so that we can use the X-ray tube.
So this image is the overview of how the generator works to supply the current to the X-ray tube to heat up the filament.
So this is operator interface, which is also known as control panel. Here, settings like voltage, current, and exposure time are adjusted to optimize image quality while ensuring patient safety. This factor is adjusted for different body parts and the condition of the patient. For example, this is usually the amount that we use to X-ray a patient's chest.
Okay, so all of this can be happen because of basic X-ray circuit and electrical power supply that brought all of this together to become one. So, basic X-ray circuit consists of primary circuit with mains voltage supply, secondary circuit, filament circuit, and other components. All in all, the basic X-ray circuit function to provide high voltage for electron acceleration in the X-ray tube, heat the cathode for electron generation, control and regulate the quality and quantity of X-ray produced, and lastly, ensure safe, stable, and reliable operation of the machine.
Captures X-ray are converted into an image by the image receptor. Modern systems use digital detectors or computer radiography, but in our hospital, we are using the computer radiography, making the process faster and more efficient than traditional field. Okay, nice. We have the grid. Function of the grid is to enhance the image clarity. It is used by placing it between the image receptor and the patient. So here is the grid, and the back is the cassette that I've reloaded beforehand. So it functions to absorb the scattered radiation that can blur the image. Basically, the grid usually is for skull X-ray. So this is the collimator. The function of collimator is to regulate the X-ray beam size and form. It is to minimize needless radiation exposure so that the operator can make sure the beam is focused solely on the area of interest by adjusting the shutter. And then we have table, which is usually motorized, so we can position the patient better on top. So next we have a bucking mechanism, which is function to hold the image receptor and align with the X-ray so that we can get perfect image.
As As you can see, the entire system is supported by structures like the tube, stand or ceiling mounted arms, allowing flexible positioning of the X-ray to accommodate different procedures.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil bin Mahfuz. Today I will explain about X-ray control panel. So, what is X-ray control panel in X-ray machine? X-ray control panel means a device which controls input power to the X-ray high voltage generator to the X-ray tube. It includes equipment such as timer, photo timer, automatic brightness stabilizer, and similar device which control the technique factor of an X-ray exposure. An X-ray control panel is a dedicated interface on an X-ray machine that allow the operator to adjust key settings like voltage, current, and exposure time, essentially controlling the parameter needed to produce a clear diagnostic image. By managing the X-ray beam produced by a machine is usually includes dials, button and display to monitor this setting and ensure safe operation. In X-ray imaging, KVP stands for kilovolt peak, which control the penetrating power of the X-ray beam, essentially the energy of X-ray, while MAS stands for milliampere second, which control the quantity of X-ray produced, essentially how many X-ray are generated during the end exposure. Key point about KVP and MAS is KVP, high KVP means higher energy X-ray, allowing better penetrating through denser tissues. Adjusting KVP primarily affects image contrast, while MAS, higher MAS mean more X-ray are produced, resulting in denser image. Adjust MAS mainly affect the image density. Now I will explain about each function of the button in control panel X-ray. First is power button. The icon is a circle with a vertical line. The function is turn the X-ray unit on or off. Next is X-ray exposure button. The icon is a hand pressing a button or labeled X-ray. Next is KVP adjustment. The icon is KVP with up down arrow. The function is adjust the kilovolt peak, controlling the X-ray beam penetration power. For MAS adjustment, the icon is MAS with up down arrow. The function is modify the milliampere second setting affecting the X-ray beam intensity. Next is anatomical program selector, APR. The icon is human body outline or specific body part such as chest, abdomen, hand or ATS. The function is select pre-programmed exposure setting for specific anatomical region. For AEC, or we call automatic exposure control, the icon is AEC label or sensor symbol. The function of AEC is automatically adjust exposure parameter to achieve optimal image quality. Next is exposure parameter display, which icon digital readout showing KVP, MAS and time values. The function is to provide real-time information on selected exposure setting. Now I will explain about safety features for X-ray control panel. Okay, emergency stop button. The function is instantly halt the X-ray emission in case of an emergency. For interlock is to prevent X-ray exposure if the system detect unsafe condition such as open door in a controlled environment. So next I will explain about maintenance and diagnostic. First we can do a self-check function, which is periodically check the system performance and alert for any issues. Next we can do a maintenance log, which keep a record of system performance, error and maintenance activities, aiding in troubleshooting and ensuring regulatory compliance. So that's all from me. Thank you.
Hi and Assalamualaikum. So my name is Iman Nuriza. So today I'm going to explain about X-ray tube. An X-ray tube is a vacuum-sealed device used to generate X-rays by accelerating electrons and having them collide with a target material. It serves as the core component in a radiographic system, producing the X-ray needed for diagnostic imaging. The tube itself contains an anode and cathode, each with distinct roles in the generation of X-rays. The cathode is the negative electrode and consists of two parts, a filament and a focusing cup. The filament is heated by an electric current, causing it to emit electrons through a process called thermionic emission. These electrons are then focused into a narrow beam by the focusing cup. So the emitted electrons from the cathode are accelerated toward the anode, which is positively charged. The voltage difference between the cathode and anode is called the kV, potential, and it is the key factor in determining the energy and penetration ability of the X-rays produced. So, the higher the kV, the greater the energy of the X-rays. There are two types of anodes, rotating anodes and stationary anodes. Each anode type has advantages and disadvantages. Let's start talking about stationary anodes. So stationary anode is literally stationary so that electron beam is focused onto one small area on the anode. Stationary anode design is very simple. However, these anodes have very low heat capacity, which also means we can only use them for very low exposures. So, this just never work for general radiography. Rotating anode is literally a rotating disc. This has the effect of spreading out those electrons over a much larger area and significantly increasing the heat capacity of the X-ray tube. Rotating nodes are essential for general radiography. Rotating anode is a little bit more complicated. However, they have a very high heat capacity with that large focal tract, and because of that, they can be used for high exposures. So this is what we call the induction motor. The induction motor is an important part of these rotating anodes. They cannot rotate without them. The induction motor turns the anode without actually touching or contacting the anode. That's why it's called the induction motor. It induces the anode to spin. The process of X-ray generation involves multiple steps. First is electron emission. So when the filament in the cathode is heated, electrons are released through thermionic emission. The intensity of this emission depends on the tube current that is measured in milliamperes or MA. Second is electron acceleration. A high voltage measured in kilovolt peaks is applied between the cathode and anode. This causes the electrons to accelerate rapidly toward the anode. Third, electron target interaction. So upon striking the tungsten target, the kinetic energy of the electrons is converted into X-rays and heat. So about 99% of the energy is dissipated as heat, while only 1% is transformed into X-rays. So there are two radiation. first is Bremsstrahlung radiation and the second is characteristic radiation. So Bremsstrahlung radiation produced when electrons are decelerated by the nucleus of a tungsten atom, resulting in a continuous spectrum of X-ray energy. While characteristic radiation occurs when an electron from the tungsten atom's inner shell is ejected and an electron from a higher shell fills the vacancy. This produces X-rays with specific discrete energies. Lastly, heat dissipation. Due to the significant heat generated during X-ray production, the rotating anode spreads the heat over a larger area and the housing oil further adds in cooling. Now, I'm going to explain one by one about what does each button do. First is digital display. So the purpose is to show essential information like the distance between the X-ray tube and the patient or other adjustable parameters. So this display helps radiographers ensure proper positioning and alignment of the X-ray tube for accurate imaging. Next is circular handle. The purpose is to use manually adjust the position of the X-ray tube. So, by holding the handle, the operator can move the tube vertically, horizontally, or angularly to align it with the patient and the detector. Next is arrow buttons. These are likely used for fine adjustment of X-ray tubes. For example, this button do for the up and down. This one is for the left and right, ensuring the X-ray beam is accurately targeted. This is the collimation adjustment. This is to adjust the size or shape of the X-ray beam to match the area being imaged. So the collimation reduces unnecessary radiation exposure to the surrounding tissues and improves image quality. So this is the emergency stop button. So this indicates where the emergency shutdown control is located. So in case of malfunction or safety concerns, the machine can be quickly deactivated to prevent harm. So, by mastering the controls of the X-ray system, radiographers can ensure accurate positioning, adjust exposure parameters for optimal image quality, and minimize unnecessary radiation exposure to patients. This knowledge not only enhances diagnostic accuracy, but also prioritizes patient safety, making it a crucial aspect of a radiographer's skill set. That's all from me. Thank you.
In an X-ray room, we rely on advanced technology to visualize what beneath the surface. At the heart of it all is the generator, which the power source to ensure the X-ray machine functions reliably and efficiently. In this presentation, I would like to tell you the component of the generator, how generator power the X-ray machine, and the importance of the generator.
Okay, next I will present to you the component of the generator. For the first, we have auto transformers. Auto transformer allow for fine adjustment to the input voltage before it is stepped up by the high voltage transformer, and it help operator to select kilovoltage for imaging. Next is the high voltage transformer. High voltage transformer used to step up the voltage from the power supply to high voltage required for X-ray production. Then filament circuit. Filament circuit provide low voltage and high current to hit the filament in the cathode. Rectifier. Rectifier used to convert alternating current to direct current. And last, we have control console, which is kilovoltage and milliamperage. Kilovoltage used to control the energy of the X-ray beam, while milliamperage is used to regulate the number of electrons and hence the intensity of the X-ray beam. Okay, next, I will present to you how generators supply power to X-ray tube. Okay, basically, the generator receives standard electrical power, typically 220 volt or 444 volts. From the main supply, the power is directed into the generator to begin the conversion process. The input voltage is regulated by an auto transformer, which allows the operator to adjust the voltage as needed for the desired kilovoltage. This prepares the voltage for further transformation. The regulated voltage is sent to a high voltage transformer, which step it up to very high level. And for the example, 30 kilovolt to 150 kilovolt. The high voltage creates the potential difference between the cathode and the anode in the X-ray tube. X-ray tube require direct currents to ensure a consistent flow of electrons. The rectifiers will convert the alternating currents from the transformer into the direct current. The steady DC power prevents electrons from reversing direction and ensures smooth X-ray production. The generator also includes a filament circuit which provides low voltage for about 10 to 12 voltage and high current to heat the filament in the cathode. Heating process causes thermionic emission, releasing a cloud of electrons in the X-ray tube. The high voltage from the generator will create a strong potential difference between the cathode and anode. Electrons released from the heated filament are accelerated toward the anode target at the very high speed. When the high-speed electrons collide with the target material, typically tungsten, on the anode, they decelerate abruptly, producing X-ray through the process of Bremsstrahlung and characteristic radiation. And I will present to you the importance of the generator. First is to provide power for X-ray productions. The generator supplies the high voltage and current needed to produce X-rays. Without the generator, the X-ray tube will not function. Next is to ensure the image quality, which to stable and precise power delivery, ensure consistent and uniform X-ray beam intensity. High-frequency generators, in particular, produce motor voltage waveform, which result in clearer and more detailed diagnostic image. Okay, next, to enable adjustable imaging parameters, which the generators allows control over critical settings such as kilovoltage, milliampere, and exposure time. Then, to improve the efficiency, modern high-frequency generators are more compact, efficient, and energy-saving compared to all those single-phase or three-phase generators. Last but not least is to enhance patient and equipment safety. Generators include safety mechanisms like overload protection, which prevent damage to the X-ray tube and generator components. Precise control over exposure setting reduce unnecessary radiation dose to patient, ensuring compliance with radiation safety standards. In conclusion, we can conclude that the X-ray generator is the backbone of the X-ray imaging system and playing a pivotal role in converting electrical energy into the high voltage and current required for X-ray production. Its key components, including the high voltage transformer, rectifiers, filament circuit, and control console, work together to ensure precise and stable power delivery to the X-ray tube. Ultimately, the X-ray generator's ability to power the imaging process with precision and reliability makes it an indispensable element of medical diagnostic, contributing significantly to patient care and treatment outcome.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sakina and I'm going to talk about the anode field effect. So, what are anode field effects? Anode field effect describes the phenomenon where the X-ray beam is more intense on the cathode side of the beam, which is closer to the cathode, and less intense on the anode side, which is near the anode scale. So this occurs because X-ray produced at the field side of the anode travel through a thicker portion of the anode before exiting, resulting in a higher attenuation, which is absorption and scattering of gas X-ray. The cathode side of X-ray travel through less anode material and experience less attenuation, making the radiation more intense.
So next, I'm gonna talk about the anode angle. The anode angle affects the path length of the X-ray through the anode material, which is the angle at which the anode target is set in the X-ray tube, typically between 7 degrees to 20 degrees. Steeper anode angles, which is closer to 20 degrees, cause a larger path difference between X-ray produced near the cathode and thus produced near the anode hills, making the anode hill effect more pronounced. Shallower anode angles, which is closer to 6 degrees, reduce the path difference and minimize the attenuation of the X-ray from the anode hill side, thereby reducing the strength of the anode hill effect. Okay, next, we move on to the source to image distance. The source to image distance, SID, plays a role in the anode hill effect in the X-ray tubes. When the SID is shorter, the anode hill effect becomes more prominent. This means that the intensity difference between the cathode and the anode sides of the X-ray beam may be more noticeable at shorter source to image distance. And next, field size. The field size can also impact the anode hill effect in X-ray imaging. When using a larger field size, the anode hill effect becomes more pronounced, leading to variations in X-ray intensity across the image. We can change our field size by a process called collimation, where we remove X-ray on anode and cathode sides of our field. Collimation is one of the benefits in field size to reduce the anode hill effect. To reduce the anode hill effect in X-ray imaging, you can adjust the positioning of the X-ray tube and the object being imaged. By increasing the source to image distance and using a smaller field size, you can minimize the impact of the anode hill effect on the X-ray image. So lastly, remember that these changes can decrease the anode hill effect, decrease the anode angle, decrease the SID, and decrease the field size.
Hi, my name is Sabrina Shazwani binti Muhammad Sabri, and today I will present about line focus principle. The focus point is the area of the target upon which the electron beam strikes. The energy of electron in the electron beam is mostly converted into heat, approximately 99%, which is why materials such as tungsten are used due to their high melting point, and they're dissipated uniformly across the focus point and anode surface. The X-ray produced at the anode comprise less than 1% of energy of electron in the electron beam. A larger focus point is therefore useful to protect the tungsten target as the heat accumulates and dissipates within the larger area of focus point when compared to the small focus point. However, a small focus point is required to achieve good radiographic image quality. The line focus principle describes the effect of the angulation of anode surface on the area of the effective focus point size or field of view. The larger of anode angle, the larger of effective focus point size, and vice versa. The line focus principle describes two focus points: an actual focus point, the area of anode surface struck by the electron beam, and the effective focus point, which is the area of the X-ray beam as it directed towards the patients. The effective focus point size can be determined by the sine of the angle of the anode surface. The angle varies as per tube designed with a range value of 6 degrees to about 20 degrees. As the anode angle changes, only the effective focus point changes in size. The actual focus point size will remain the same. Therefore, a change in the anode angle will not influence the heat capacity of the anode as the actual focus point remains unchanged. Actual focus point is the area on the anode struck by the electron beam that determines the heat capacity too. For a smaller target angle, the field of view covered by the X-ray beam will be smaller, so it's not possible to cover large area at smaller focus film distance or FFD. Therefore, it can be appreciated that choice of target angle is not compromised between geometric unsharpness and desired field of view. For practical purpose, at 40 degree FFD, the anode angle should be no smaller than 50 degrees. A decrease in angle below 6 degrees will result in anode hill effect. So next I will present about X-ray filtration. So X-ray filtration is referred to the process of removing low energy and non-diagnostic X-ray photon from the beam before they reach the film. So filters are used to achieve this and enhance image quality and reducing the patient's radiation dose. So there is three types of filtration. So first is inherent filtration. It's provided by the X-ray tube and housing itself. Includes the glass envelope, insulating oil and tube window. Typically equivalent to 0.5 mm aluminium. So next is added filtration. So added filtration placed in the X-ray beam path, usually made of aluminium or equivalent material, used to meet regularly requirement to total filtration. So next is compensatory filtration. It's a specialized filter such as wedge or through filter used to balance exposure for body part and varying thickness, ensure uniform image density. So here's the purpose of filtration. First is the patient dose reduction. Remove low energy photon that would be absorbed by the patients, minimizing unnecessary exposure. Next is improve beam quality. Harden the beam by increasing the average energy of X-ray, resulting in better penetration and contrast. So here I do some comparison between line focus principle and X-ray filtration. So for the purpose of line focus principle is to improve the image sharpness and heat dissipation, while the X-ray filtration is to reduce patient dose and improve the beam quality. So for the mechanism of line focus principle is use an angulate anode to create a small effective focus spot, and for X-ray filtration is use filter to remove low energy X-rays. So for the impact of image quality for line focus principle to enhance the spatial resolution, and for X-ray filtration is to increase the contrast and uniformity. Last but not least, the patient safety for the line focus principle is to indirectly improve safety by enhancing the image quality, while the X-ray filtration is directly reduce the unnecessary radiation exposure. So both principles are essential in achieving while ensuring patient safety and equipment safety. So that's all from me. Thank you.
So next, I'm going to talk about X-ray filtration advantages and limitations. So X-ray filtration is beneficial in medical imaging as it helps in reducing patient dose by removing low energy X-ray that contribute to skin dose without significantly affecting image quality. Additionally, filtration improves image contrast by reducing scattered radiation, resulting in a clearer and more accurate diagnostic image. One limitation that excessive filtration can lead to a decrease in image brightness, which may affect the overall image quality and diagnostic accuracy. Okay, that's all from me.